It's a couple minutes past 1 or a couple minutes past 12, depending on where you're at. Welcome. My name is Kevin Leech. I work for CDT. We are a value-added reseller. If you're having problems getting to your computer screens, on the email that you should have got on the invite, there is a telephone call-in, but there are no toll-free things. So if you can listen over the computer, great. I have everybody muted. There will be time for questions after the demo, or you can write the questions back in. This is going to be a demo for, let's see, before we get into that. So I'm an applications engineer, PTC certified trainer. I go around, I train. We have training courses in Kansas City, Arlington, St. Louis, Charlotte, Cinnamington, and Orlando. We cover everything from Windshield, Creo, MathCAD, and Arbortext. If you need any more information about that, or you want to look on the website, it's right here at the bottom. We'll be able to assist anybody that needs more information on pretty much anything that they're interested in. And today's demo is basically going to be on the basics of 2.0 turning demo. So it's just very, kind of going to go over the high-level end of the turning process. And again, if somebody wants a little bit deeper or more information on something in specific, if we get some emails back or questions at the end, we'll kind of get back to you and go from there, right? So manufacturing turning process basically broke down into four steps. First, you create the manufacturing model. Obviously, you have a model, a ProE model, or a model you brought in. You create the manufacturing model, add that model to it. You control your environment, tell it what machine. You give it a reference for your coordinate system. You set up your profiles, your tools. You create sequences. You then export out the CL data and go to your machine. So we're going to do a couple things today. We're going to play around with some basic setups. We're going to talk about some material removal processes. We're going to show Vericut a little bit so you can see how to get out the Vericut on a sequence or two, the advantages of using some of the Vericut. I'll try to show some of the things that I've come across as far as how to set some of this up. We're going to talk about profile turning, right? So some basic parameters that you can set up for stock allowed, Z-stock, tool orientation. There's an outside area turning. So these are mostly just the very basic beginning steps. There's about 3 of them that we're going to talk about in this little demo. I'm using Creo 2.0 today. So again, if you want to see something later on that's specifically about Wildfire 5 or one of the other ones, just let me know. And we're also not using Windshield in this case. I'm using a network drive. So specifically, for me, I'm setting up a demo for the turning. If this was my day-to-day kind of jobs and I was using a network drive, I would have it start in a specific directory. It picks up the secondary config.pro, which if I was looking at Windows Explorer, carries a lot of my, where my fixtures are located, wrong demo. Here we go. So config.pro, this carries a lot of that basic information, right? So what units I'm in, whether to turn on the displays, but more importantly, my template design information, my drawing templates, my solid parts, my manufacturing start parts, search paths for all my fixtures and tools. So a lot of times if people want to get into solid tools, you really have to have your setup correct. This config.pro points back to, again, there's my solid tools directory. The manufacturing library comes from PTC. You can download it on their website. I have a fixture directory where I might keep some fixtures, right? So we can look at some of those. It might be a tool head, a dual head turning lathe, or it could be a simple chuck, right? I might have 5 or 6 different lathe chucks set up for fixturing. So to me, some of the more important stuff out of all of this is getting started, getting a setup where everything works together and the system is intelligent and it's going to find all my parts correctly. I then have a directory in here called work directory, and again, this could be anywhere on a network somewhere, but basically I have my projects all broken down. I work within those projects. I set my working directory. I'm very clean and clear with what I'm doing while I'm in there. So in other words, I don't work on one project and then go, oh, I'm going to work on something else. I save everything in one project. I keep everything in the same directory. I have my fixture, set up so it'll go find stuff. And today we're just going to we're going to work on a simple part here. This is just a revolve tool. So if we looked at this and edit the definition here, we'd see it's just a simple revolve. And we're going to go and do some turning on this. So there's my part. And again, this is Creo 2.0. So if you guys haven't been seeing Creo 2.0, it's all ribbon oriented. Everything's located up on the top. We have a quick access toolbar, so things that you used to have to go to further steps to get, are much easier and cleaner to get to. Right? Dashboard oriented, a lot of the tools. So we're going to go and we're going to create an NC manufacturing in this. So we'll say File, New, Manufacturing, and we'll just say Bottle, NC. And I've made a couple of them, so I'm just going to call them NC5 just so I know that it's specific, which one I'm using. So when I come in, the very first thing in manufacturing, whether it be lathe, mill, whatever, is I want to tell it what I'm going to do. So I'm going to go in here and just use a lathe tool. It's going to be a single turret, so I'm just going to leave this as a default. I'm then going to create an operation based on a lathe tool. Right, so it knows it's lathe 1. I'm going to add my fixture. So this is, again, it's all dashboard oriented here, so fixture setup. Go find my spindle. Go to assemble it. I know that I've got it all assembled the way I want, so all I got to do is hit default. Done. I already have a start coordinate system in based on my turret. Let me go back there 1 second just to make sure I didn't miss nothing. Oh yeah, I can set up my clearance while I'm here, so I can set clearance to a plane, and I can use something like the front jaw there to specifically give myself some clearance. I know that that bottle I'm going to work on is about 7, so I'm going to go to about 8 here, or 9. Let's go to 9. Right? So that's my retract plane basically. There we go. So now I have a lathe set up, I have my fixture set up, I have my operation set up, right? And again, if I wanted to turn off my fixture at some point, I don't have to go delete it. All I got to do is go to my fixture setup in the operation, right-click and say hide. So I can turn that on and off as needed. Oh, I didn't really want to remove that though. That wasn't my goal. Right? So there's my fixture. Like I said, I can hide it. I can unhide it. So it's right there for me. You might have multiple operations. You might have, a couple different operations on the same part. You might need different machining stuff. You can put the different fixtures in as needed, right? Save often. Right? We're going to add a reference model, which happens to be that bottle, right? We can bring it in just as it is, or we can bring it in as an inherited model or a merged model, right? A couple different options here. We're just going to bring it in normal. And again, I got to assemble it. So circular, works well. Right, that's a coincident constraint. Now again, if you're not used to Creo 2.0, they've kind of renamed a lot of the constraints. Insert, mate are all kind of going away. They're all coincident now. Right? So if we go up and look at the placement, you can see coincident. And you can see our options are a little different than what we're used to in Wildfire 5 if you've not seen that. And I'm just going to add a constraint from there to there. And I might even leave a gap here. So I might leave a distance. And I might leave a 250 thousandths clearance there because I'm going to put a workpiece in to hold this in anyway. So I know that I kind of want to be away from my jaws when I finish this. I might even be further away. But that's good enough for now. There's my workpiece that we're going to work on, and then we'll add a workpiece, right? So an actual material removal type piece. You can see it's kind of automated. It wants to go to a square. In this case, obviously, I don't want a square. I want a cylinder. And I might want to control some of these dimensions. So if I go into options, so I can go into 9 and then go, you know what, I really want most of this to come on this side and very little on the front side. So I'm going to expand this to maybe 1.250. And then I know I'm 0.59 bigger than I want, so I can just come over here and say minus 0.59. And now I have 9-inch overall. I have 1.25 inches to the left inside the chucks. And I have just a little bit outside 70 thousandths on the front, which is pretty good. I also want to change my diameter of my workpiece to 3, just because that's a more common size, and say OK. Save my model. And I'm off and running. So now I've got my lathe machine set up. I have an operation set up. I have a piece of machine inside there with the bottle, and I have a workpiece to kind of see what I'm doing. And these are my normal techniques. I will start the same way. Now, if I'm doing a lot of this, I might even set templates up that automatically pull in my lathe and my spindle as a fixture, just as a template. That could be part of my manufacturing template, and it could come in automatic. So I could eliminate a couple of those steps right from the very beginning. We're going to go back now and we're going to do some turning, right? So there's a tab up here called turning. We're in the manufacturing tab now. We're going to slide out of here and go into the turning tab. And we're going to do a simple profile turn. Now, I'm only doing a couple of these today just to kind of give you an idea of how some of this stuff works. But the profile tab comes up. It's a dashboard-oriented piece. There's my tool. I'm just going to add a simple left-handed tool here. Here's our parameter box. You can see by my screen the yellow, brighter yellow, as stuff that is needed in order to continue finishing this sequence. It doesn't really care how much stock I want to leave, although I can manipulate the stock. It really needs only the cut feed and the spindle feed to get started. So we'll put that at 10, and the spindle speed is like 3,000. Tool motions is next, and you can see it almost kind of lights up. The minute I finish this, it lights up and says, hey, you know, kind of look at me over here. Click on the tool motion. We want a profile turning cut. Opens up the profile turning cut box, which then I can go in here and say profile turning, and by default it grabs the edges of my part. And I could drag these, say OK. I can adjust the start and end points here, so I can go in here and change some of these points if I want, move it up or down. All right, same thing with the end. But that's good enough just to kind of see what we got going on here. And I can hit my play. And you can see I got a cut. Before I leave here, though, I might go into the parameters and say I want to leave an 030 stock allowance, or 010 or 020, or whatever I want to leave, 5 thousandths, whatever I want to leave in there, and say OK. And that's my first profile. Now, what can I do with that? You know, it's hard to really verify or to see what's going on with just a simple play path. Even if you slow it down, it's hard to see what the back of that tool is doing. You can see it's crashing through my model here because it's trying to follow those cuts down. An easier way to see this, or a more visual way to see this, which is kind of what I like, is to take it out and do a quick geometry check using Vericut. So I go back to manufacturing, do save a file, because what I'm going to do is save a CL file, computer language file, to kind of control this. I'm going to base it on the operation that we have, which is op10. Right, so this is the operation. We're going to save it to a file, op10, and say OK. Done. That creates the CL file, which we then can use to run the material remove simulation. Pick that same file I just created, say open, and done. And this will launch Vericut, which hopefully will look good over the web. I wish I had another one going. I could watch my my own little show here to see how this looks. But this is Vericut, and Vericut is a real useful tool to kind of see what's going on inside here. And we can see in the red where we're crashing into our model, which is not what we want. I can also do some other things in here. One of the things I like to do a lot of times is I will go in and create a multi-view, so like a 3-view preview of this. We'll reset this real quick. And then I'll go View Orient, pick this box and say, all right, I want to see that as a horizontal ISO. Then I might want to see this one as XY, or let's say ZY, and maybe leave that one a little more zoomed in. So I like Vericut because it gives me a great advantage of kind of watching this. I can slow down the machine animation if I want to. And you can see all three windows are kind of updating, and so you can kind of go from one to another and get a good look of what's going on. So we clearly got an issue here. I can go back, just close Vericut, come back in here, edit the definition of my profile turn. I can either add more standoff for my stock, or I could say, you know what, I don't necessarily want to use this just simple profile. I might do this a little bit different. So instead of doing it this way, I might go in and say, all right, let's delete that. It will do it again. We'll go back in here and say profile turning, and instead of grabbing the default, same tool, same parameters, and we'll leave 5,000. When I go to my tool motion tool here, and I go to my geometry, instead of just letting it pick the one that it wants or the edges that it wants, I can actually go in here and say, I'm gonna sketch my profile as opposed to letting it choose my profile. And basically I can go in here and sketch. So we can go in and use the edges that we want. Oops. So I might not want to go down in here at all. I might want to just skip right over here. I'll come back to that in a second. This is going to be a sketched one. I'm going to draw a line to connect this stuff. This will keep me out of these little alleys. Now I could have came straight across there and used the edge up and around if I wanted to, but this kind of just gives me a little bit more control over where I'm cutting and where I'm going to. I change my start point. All I got to do is pick the point I want to go to and say start point. Finish my sketch. Say OK to my profile. Say OK. I can hit play here to kind of get a view of this. Right? And we can see how we're not gouging into the part. And then I can come back with a groove afterwards. Right? Maybe change the angle there or get a little bit more of a standoff clearance here. So maybe go back in and say instead of 5, let's go 10. Try one more time. So I try to use multiple tools to see what's going on, and it might be that this is not a bad way of kind of seeing what's going on, but the Vericut might give me a little bit more view of that. So get done with it. Come back out to manufacturing. Save the file again. So I'm going to resave my CL file based on the new operation. Overwrite the original CL. And then go out, material, remove, CL file, and say OK. And let's go back in and take a look. So for me, my biggest thing is I'm really trying to get as much information done in the computer as possible so that I don't go out to the machine and have to fight with the machine as much. That's really what we're trying to accomplish, is so that you can get as much of this much of this legwork done up front. It helps too, like I usually have two monitors going here at the same time so I can see these things a little bit better. But you get the idea. I'm just kind of doing the same thing I do. Go back. I'm still nicking it a little bit. So close. And I was kind of concerned right here as I was coming up over the top when I was watching my profile. But that's simple enough to come back in, edit the definition, and one more time come into my parameters and say, all right, let's use 020, and then I'll come back with a different tool and finish that up. So I've got plenty of room here on my rough. Do it one last time just to verify. Say OK, done. Pick my NCL, say done, and we'll go back in and we'll just check this real quick. Now I won't go through the orientation this time. I'll just kind of come in here and get a better look. And hit play. So I'm still getting a little bit, not bad though. And that's kind of my, the way I'll go through these steps is I'll be very patient, keep saving my model, keep verifying, keep checking, and kind of work up to it, kind of sneak up to my deal. Now if I had multiple steps here, like a face mill, or not a face mill, but a face turn where I come in and face it, then that will come in as well. And you can send multiple pieces out. You can also do the automatic material removal. So if I'm happy with this cut and I want to see what I have left, a great tool built into Creo 2.0 is called Command Search. So if you can't find something like remove material, you just start typing it and you get material remove cut, which is under turn, manufacturing geometry, remove material cut, right? Pick the sequence you want to remove it, do automatic, done. Oops, I don't know what happened there. I didn't like something. I did that a little bit earlier. It worked fine. I'm not going to fight with it while we got you online. But basically, that's the material removal deal. That could be because I'm crashing into my part a little bit here. Save the model and finish up. So I showed a couple there. One was the profile where I just grabbed the edges, let the system do it, and then the next one is to actually go and sketch your cut, right? So you can create that sketch any way you want. The other thing I wanted to show is, boundaries not displayed, it's just an outside area, the same kind of concept, but a little bit different. So this one I've already got the lathe created. I already got my operation created. I want to go into turn, say area of turning, grab a tool. So this is just going to be a rough outside tool. Give myself some parameters here. So I need an extra parameter on this area turn that I didn't have in the last one because we're going to take multiple cuts. So we're going to go 0.1. We're going to go spindle speed of 500. Same deal, right? Tool motion lights up saying, hey, this is fine, but you need something more than just parameters, so you need some tool motion. We're going to do an area turning cut. We're going to use our geometry selector here, and this time instead of using the original one they give us or a sketch, I'm actually going to use surfaces to define the turn profile. And basically, if I grab this one, in this one, it will create the path based on those surfaces. Right? And again, I can go in and I can adjust this and say, well, you know what? I want to be a little more than that past it, so maybe I'm going to go minus 0.5, and you can see I can extend that cut out if I needed to a little bit. And same thing on the back end. But there's my cuts. And I just had Pro eat crap out. Great. that was a pure Windows display driver that just killed me. Do that one more time. Sorry about that. Working directory outside. Normally, too, if I do crash, which happens once in a blue moon, it is Windows and Pro E together. They don't like each other for some reason. But if I do crash normally, I would stop, shut my computer off, go get a cup of coffee, come back and do it again. But because we're doing a demo, I'm going to try to keep going here. I'm only saying this just in case something goes wrong again, because that's why I like to stop and start over. Right? All right. So we have our operation, we have our workpiece, we have our beginning start stuff here. We're going to go in and create an area turning. Pick a tool. Go into parameters. Give it a step depth. Give it a spindle speed. Tool motion. Area turning. I'm going to use surfaces this time. We want to go from here to there. Say OK. You notice I'm going a little bit slower this time. I don't know if it's a visual problem that I just had or not, but I don't want to find it again, so we're going to take our time. Play path. And you can see our cut. So same thing goes here. You're going to take this off the manufacturing, save the file, operation, op10, file, save it to the work directory, go to my material remove, and then run through Vericut, just like I did on the last setup. I can set my multiple windows again, view layout, standard, 3. This one's not very complicated. So again, if you're not using this, this is a great tool. I really do like it. I like the ability of slowing it down. There's ways to have it stop if you had multiple tools. I do this a lot with machining where I have multiple tools, where I have it stop between tools. Every time it switches tool, it'll actually stop for me and wait, so I know in different colors. And here's a outside area, very easily, very quickly done. And again, I could have set the fixture in here, which could have had my, base NC coordinate system. I had my base vice set up and been off and running. So I get a great visual telling me what I've got. The red lines in there kind of tell me, hey, you got 0 clearance or nothing left, and I can go back into this, go into my parameters and say, oh, I really wanted to leave some stock. Resave it. So it's just the little things for me that kind of jump out and say, when I do the material removal using the Vericut, that really kind of makes my life easier. It's quick, it's easy. I can see what's going on. I didn't bring it out to the machine and then go, oh, I forgot to do something. So it just really is a great tool. I really like it. And that's really pretty much what I had set up for today. Just a couple of quick, easy demo stuff. It's been about 35 minutes, about 30 minutes of this. I don't have much more than that set up. I think what we're going to do, though, with the turning is this was a very basic start turning process. One of the next demos might be a little bit more advanced demos. We'll get into some groove and threading, maybe some drilling. But basically, it's the same techniques. You're building sequences by selecting tools, selecting the geometry to remove, and then running through the sequence with parameters. That's about all I got. I'm going to look in the window here, see if I saw any real big questions jumped out. I got, let's see what I got here. Yes, that was about it there. Look at my slides real quick. Yeah, so I'm going to put my information up here to finish off. If I can figure out which screen that is.
And Kevin, we do have one question from Mike.
Okay.
The question is, can you use Vericut geometry, Vericut geometry file for material removal?
I use Pro-E to create the CL file and then use that to create the Vericut removal process. I think you need the additional license from Vericut to do anything more than that. Vericut is an outside program that PTC purchased a certain amount of license to go along with it, so you get some basic use out of the Vericut. I don't think what he was trying to accomplish can be done without an additional Vericut license. As you notice, I can bring that back up too. As you notice when you went out here, or when I went out here, Vericut has a whole lot more in there than what I was doing. All I was doing was running through the CL data file from Pro-E. But there's all kinds of tools built into Vericut. It's its own tool to itself. And like I said, Pro-E purely just buys enough information to kind of get going with it. People set up all kinds of, I've seen setups where they have machines built into this and simulate the machines and look for tool crashing. You can also do that with Pro-E too. You can do machine crashing with Pro-E with Mechanism. I've seen that as well. But the Vericut is a bigger tool, and what Pro-E buys is purely basically to run the CL file. Was that the only question, Rosalinda?
That's the only one, yes.
Okay, so like I said, people, I know it's a little bit quicker than what maybe you were expecting. I did not want to keep everybody through the entire lunch deal.
Another question just popped up from Mike.
Go ahead.
And he's asking, what about tool organization in the tool library?
What about it? Can we somehow make his mic live so I can ask him a couple questions where he's trying to go with that?
Yes. You're unmuted. You're unmuted, Mike.
Mike, are you there?
Yeah, I'm trying to be.
Okay.
Can you hear me?
I got you now.
You got me now? Okay. What I'm wondering about is the setting up multiple layers in the tool library so that you can, whenever you get a lot of tools in the tool library, you start getting to the point where you can't find stuff. And trying to organize that tool library, how do you guys do that?
So for me, I mean, Lead is probably a little bit easier one because it's not like milling where you might have 50 or 60 different tools.
Oh, I'm talking hundreds.
Oh. Yeah, I have never had to work with that many tools in to be honest with you.
Well, even stop and think about it a little bit. If you have all your drills, if you have your 16th-inch drills, then you have some metric drills, and then you have some number drills, you have some letter drills, and then you have them in 2 or 3 sizes because, of course, you have the stub, and then you have the regular length, and maybe even have the long length, okay? Can you see how you can have a whole bunch of tools really fast?
Yeah. So what I just did, and you can still see my screen there, right?
Yeah.
I just went to the cutting tool setup box, did a file open. Now I have my standard tools set up. These are also like solid model tools.
Yep.
So, basically what PTC has kind of done in the past is they built a lot of this stuff into family tables, and then you're able to pull this stuff out of the family table. So if your family tables are fairly organized, it makes your life a little bit easier. But, when you start talking about what you're saying, where you got thousands of tools,
yep,
it really becomes you need to do a great job of organizing your tools in folders so that they make sense. So here's my drills.
Well, that's what I'm wondering. Like, if I organize them into folders, and then as I try and save, if we're working on aluminum today, and we're working on stainless tomorrow, and we're working on steel the next day, these tools all have different feeds and speeds in the same tool that is saved back under the different materials. And if you drop those into, it only drops your tool into one folder, the folder that's pointed in your config file.
Right.
So how do you get around that? How do people get around this? I know I can't be the only guy that's ever come up against this.
No, I'm sure you're not. I have not come up against it myself. So what I can say to you is, I don't have an answer for you today. There's no one answer to give you that to you. What you could probably do is get me an email. We'll start corresponding, and we'll try to get some kind of feedback based on your questions, and try to find some people that are doing the same things, and see if we can't get that a little bit more organized.
Okay, that's fair.
I mean? I don't know. I just don't have a better answer other than I would really try to locate folders and try to get things organized that way. But you're trying to get the machining parameters built into them to get speeds and feeds. It definitely gets complicated. I know what you're saying is exactly.
Yeah, and my question on the Vericut file was more like whenever the Vericut creates the material removal. Okay.
It doesn't really create it, right? It
creates it whenever Vericut's running off of your CL data, it's taking your basic stock and it's creating what is left from your basic stock off your CL data there. So it creates a file.
Yeah, based on your CL file, yes.
Yes, based on your CL file. And what I'm wondering is, can you use that file that's based off of your CL data to actually do the material removal for in your next operation or next setup in Pro?
Not that I know of. So I use Vericut only to verify. So I know what you're trying to accomplish there, but I don't know that.
The material removal doesn't always work correctly.
So you run something through on an NC sequence, you export it out or save it off in a CL file, run it through Vericut, and then when you do the post, it doesn't actually come out the right way.
Well, what happens, this is more in milling than it is in turning, but in milling, if you create a pocket and you're using a 1-inch end mill and it has a 1/2-inch radius on it, but yet your pocket only has 1/4-inch corners on it, okay, that 1/2-inch, there's still a 1/4-inch left in those corners. Well, that material removal, until you go in there and figure out what is actually left, and you have to calculate it and tell it for the material removal, it doesn't do it.
I lost you again. You saying Vericut doesn't do it or Pro E doesn't do it?
Pro E doesn't do it. Vericut doesn't.
So if you go back through NC check, it doesn't. So the old way was NC check. You've used NC check.
I actually have always used Vericut, but it doesn't. What you're looking at is just you're just looking at a representation on the screen. You aren't looking at the actual data that is being used to make your next sequence.
Yeah. So I'm.
You understand what I'm saying?
I kind of do, but I've never had these problems that you're talking about, where I run a CL check or I run a CL file with a certain thing, and the next time I use it.
Could I call you?
You can call me directly.
Okay.
My phone
I'll give you a call after sometime. And
yeah, my phone's up there. I don't, like I said, some of these questions are definitely deeper than where I was heading today.
Okay. Yep.
And need more like specifics, like you were starting to head down. So if we go back and forth, correspond, emails, I don't mind helping you out and try to figure out some of these issues. There are definitely people that know more than I do as well. This is not what I do every day, the machining part of it. I'm more of a designer guy, so I got a good machining background. You know what I mean? I've been using this for about 15, 16 years, but that doesn't mean that I'm, 15, 16 years of manufacturing part of that. You got me?
I got news for you. I've been messing with it for 5 years, and I haven't even scratched the surface.
Yeah. So that's kind of, I tell everybody the same thing. Like, I don't like using the words expert and that kind of stuff because when you think you know it, you still don't know it. So I'm willing to work with you and try to help you out. No problem. My email, my phone number's up there. If you want to get us or email me, we'll work stuff out.
Okay, thank you.
No problem. How's everybody else doing? Is there anybody else out there, Rosalinda, or was that about it?
I believe that's it. I see no more questions.
All right. I appreciate everybody. Like I said, people, I plan on doing a couple of these in a series so that this would be more of a startup, beginning late, and then there'll be more of an intermediate with a little more tools, and then they'll finish up with a more complicated with the post-processing and exporting out and that kind of stuff. So I appreciate everybody coming today. You guys have the rest of your lunch. Enjoy it. We'll pick it up in about a month or so. I appreciate it. Thank you.
Thank you.